All right, using the same methods that we talked about in the first part of this section, you can add three vectors together, or more than three vectors together. So I wanted to look at least one example of adding three vectors together, and I'm choosing to look at an application problem so we can kind of kill two birds with one stone. So this problem says that in order to move an ocean liner into the channel, three tugboats exert the forces shown in this figure. And we want to figure out what is the resultant of these forces. All right, so this is the ocean liner, right? And these are our three tugboats that are pulling on it. So it's three vectors we can use to represent this scenario because there's a force that is being exerted from each of these tugboats that are pulling the ocean liner, and they're all going in a certain direction, right? We are going to have to name some things to be able to organize our work. So let's call this vector A, this will be vector B, and this will be vector C. Now I want to also come up with what are the angles and standard position for these three vectors. So I'm going to call that theta A, theta B, and theta C, because we're going to need that when we try to find the components. Alright, that was off the screen a little bit. So if you look at this, since A is going straight towards the east, right, its angle and standard position there is 0 degrees. B, we see that it's 15.5 degrees rotated towards the south off of that east line, but when we write our angles we want standard position, so we actually want to look at this as the positive x-axis and our angle wrapping all the way around, right? So we want to take 360 degrees and subtract the 15.5 degrees, which is going to give us 344.5 degrees for the angle B. Okay, and then for angle C, same idea, we're going to take 360, and this time we're going to have to subtract both of these angles here, the 15.5 degrees and the 22.2 degrees, so that you can get 322.3 degrees. All right, now our first goal here is going to be to find the components. So we need to add these vectors together, so we need their components. So we're going to find the x component of A, the x component of B, the x component of C, the y component of A, the y component of B, and the y component of C. Okay, so the x component of A is going to be found by taking its magnitude, which is 5,500, and multiplying that by cosine of the angle, which is 0. Alright, so if we work that out, you get that it just equals 5,500. The y component for A, we would take 5,500, multiply it by sine of 0 degrees, which is gonna give you just 0. Alright, the x component of B, we're gonna take 6,500, multiply it by cosine of its angle, which is 344.5 degrees. And what we get here, we would enter that into a calculator, but I did this earlier. You get 6,263.6 approximately. Alright, the y component for B, you're going to take 6,500, now times sine of 344.5. And that is going to be approximately negative 1,737.05. All right, the x component of c, we're going to take 3,500, multiply it by cosine of its angle, which is 322.3 degrees, which will give us approximately 2,769.28. All right, the y component of c, we're going to take, it'll be the same thing, 3,500, but now multiplied by sine of 322.3 degrees, which is about negative 2,140.34. All right, so now we want the x components and the y components for our resultant vector. So for the sum, now all we need to do to figure that out is add these together, right? So if we add these, we're gonna get our Rx, the x component of the resultant. So I'm gonna go ahead and just do that. It's gonna be 5,500 plus 6,263.6 plus 2,769.28, and you get 14,532.88. And then do the same thing for y. And if you do that, you end up getting, so we would add together 0, the negative 1,737, and the negative 2,140, and you end up with negative 3,877.39. Okay, so we have all the components. So step 2 now is to find the magnitude and direction of our resultant vector. All right, so step 2. Find magnitude and direction of R, vector R. To get the magnitude, you just take the square root of the x component squared plus the y component squared. So these two numbers squared and added together. All right, we're gonna go ahead and write this out. 14,532.88 squared plus negative 3,877.39 squared. And what we get from that is approximately, when you work it out, it's approximately 15,041.2, but as far as significant digits go, and I think that's how, they would want you to answer this on your My Math Lab assignment, we only have 2 here. So they would round it down even further and say that this is approximately just 15,000. So this represents 15,000 pounds is what the force is acting on this ocean liner altogether with all 3 tugboats pulling on it. Now, we need the angle, right? So to get our reference angle, we are going to take the arctan of, you always take absolute value, right? And you're going to take the y component, the absolute value of it, which is 3,877.39, divide it by the x component, 14,532.88. Okay, and type that into the calculator. If you do that, you get that this is about 14.9 degrees. Now, judging from the picture, right, I'm sure you can tell that it would be 14.9 degrees. That would be off of the horizontal, so going down into what we would consider like the 4th quadrant, right? If this is the origin, it'd be pulled into the 4th quadrant. Actually, if you look at your components, see the x is positive and the y is negative. So what that means is that vector r is in quadrant 4. All right, so if you wanted your angle, you could take 360 degrees and subtract the 14.9 degrees. So you get a 345.1 degree angle. That's the direction it's headed in. I think when I looked at the answer in the book, they might have worded it like this. So I'll just say or. You can say this is about 15 degrees from the force that was pulling it straight towards the east. So 15 degrees from the 5,500 pound force. That's how they had it worded. As far as on a test goes, I would accept either answer because you're showing that you know what you're talking about with either one of those two answers. All right. So yeah, that's how you add 3 vectors together, and this is an application of a time when you would want to add 3 vectors together.